Cross-functional teams often lack boundary objects for collectively defining and developing AI. We report on how AI onboarding ended up serving as a boundary object between team members while developing an AI for medical diagnosis. AI onboarding is introductory training materials for users to see prior to their use of an AI. For example, doctors can first be introduced to an AI via onboarding prior to making medical decisions with the help of AI. Here's an example of onboarding materials for an AI for prostate cancer diagnosis. From prior research, we found these categories of information particularly useful for doctors to learn about an AI during onboarding, such as its source of ground truth, its strengths and limitations, the ways it might act weirdly compared to human ways of thinking, and an actionable tip so that users know when to rely more on the AI and when to rely more on their own expertise. Here are a few examples of how the process of creating onboarding changed our team's understanding of user requirements. First, we found that giving people metrics about the AI was not enough because metrics alone aren't actionable. Users wanted actionable strategies for knowing what to do in cases where they disagreed with the AI's predictions. As a result, the team needed to translate typical performance metrics like accuracy into metrics that could be more actionable from the end user's frame of reference. And through doing this, the team developed a shared understanding of how end users assess models during diagnosis. We also found that users wanted to know which edge cases the AI had been designed to handle. For example, in their own medical practice, doctors find certain types of medical subpatterns particularly difficult to diagnose, like paraneural invasion. They wanted to know if the AI similarly struggled with those special cases, or if the AI had specifically been designed to handle them already. However, this information was not easy to uncover since the data did not always contain edge case labels. Moreover, relabeling the data could be quite a taxing process. Ultimately, the team realized that labeling subpatterns and edge cases could actually serve a dual purpose. It could help improve the model, and it could help provide transparency on edge cases during onboarding. This reflection raised awareness about how labeling subpatterns and edge cases could be mutually beneficial moving forward. One aspect that's valuable to provide up front during onboarding is the ways that AI can seem weird or bewildering compared to human ways of thinking. Explaining these idiosyncrasies can help set user expectations early on in their exposure to the AI. However, knowledge about the AI's idiosyncrasies was often distributed across team members, with different people having noticed different quirks about the AI. As a result, we aggregated this knowledge across team members and explained those odd behaviors during onboarding. This process of collecting that information actually fostered communication between team members about the differences between AI versus human ways of thinking, and led to a better group understanding of user expectations. In a study we conducted with 17 pathologists, users felt that onboarding helped them collaborate better with the AI. Most importantly, they felt it helped them understand its strengths and weaknesses, which helped them develop a strategy for working with it. Users were given an actionable strategy during onboarding to use during their diagnosis with AI. Those who recalled the strategy also had higher accuracy overall compared to those who didn't. In conclusion, future teams could consider using onboarding as a boundary object for developing AI assistance. To get started, cross-functional teams could jointly create onboarding materials by filling in these 4 topics together, such as teams could answer questions like, how does the AI behave weirdly relative to human ways of thinking? Or, when users perform this task in their current work contexts, which special cases or edge cases do they care most about? Among those edge cases, which ones does the model perform well on, and which does it struggle on? Or, if a user is deciding when to trust the model versus themselves, what tip would you give them in your own words? In sum, we found that this process of creating onboarding had a side effect of facilitating the crosstalk between machine learning, HCI, and product management as they jointly iterate between understanding user requirements and developing the machine learning model. We hope future teams will consider using onboarding for developing AI assistance.